Let's start. Dear conference participants, it's a great pleasure for me to be a moderator of this highly professional event. I'm a Professor Denis Sviridенko, Deputy Director of the Belt and Road Initiative Center for Chinese European Studies at Guangdong University of Petrochemical Technology, China, Vice President of the International Society of Philosophy and Cosmology, Ukraine. Being a partner of Science and Space Design Bureau, and additionally having my educational background at the National Aerospace University named after Zhukovsky Kharkov Aviation Institute, I've been picked as a moderator by the conference organizers. It's a great pleasure for me to see many space, air and sea theory and industry representatives as the participants of the conference. Let me share some technical details of the today conference. We have 6 presentations, which one has duration about 15 minutes. We have possibilities to make discussion section after each presentation, up to 10 minutes. I promise to do my best to guide us through the program, making possibilities for experience exchange and fruitful discussion. Given a history, Ukraine is the 3rd spacefaring nation in the world. The Soviet Union launched the world's first artificial satellite at October 4, 1957. The United States on February 1, 1958. The Ukraine on March 16, 1962. The satellite was launched into Earth orbit by the space carrier rocket developed by the Southern State Design Bureau and built at the machine building plant named after Makarov Pindan-Mash. Unfortunately, until this year, Ukrainian private companies had no legal right to engage in space activities. Only on January 29, 2020, this ban has lifted. To tell the truth, much time has been lost. Nevertheless, the design and rocket building potential for development and launching carrier rockets in Ukraine is preserved. There are only 7 democratic rule in law countries in the world capable of developing, constructing and launching carrier rockets, and Ukraine is one of them. In today's world, private companies have begun to develop and implement space technologies, and private business goes into space. We are holding this conference to attract investment in the development of space companies. Today, several presentations of specific rocket designs and new technologies developed by the Science and Space Design Bureau will be featured. So, dear participants, the space technologies will give you an opportunity to increase the capital and make your country spacefaring one. So, after my welcoming speech, it's a great pleasure for me to invite Professor Valentin Levenko, the president of the Science and Space LLC, to make his welcoming speech. We can't hear you. Please switch on your microphone.
I'm sorry. Good afternoon, ladies and gentlemen. I am Professor Valentin Levenko, and I welcome you to the 4th Scientists and Business Conference Space, Air and Sea Ukraine. Thank you very much for taking part in our conference.
Thanks a lot for your welcoming speech. It is a time to start our first presentation. I heartily welcome Inessa Kostenko to make a presentation of report legal regulation of extraction of natural resources of the moon and other space bodies. You are heartily welcome.
Thank you. Glad to see everyone at this conference. I'm very grateful for this opportunity to be a speaker. Let's get started. I'm Inessa, a senior researcher at the Research Institute of State Building and Local Self-Government of the National Academy of Legal Sciences. My research is devoted to the draft law of Ukraine on the use of space resources. Today, the issue of regulating the extraction and use of space resources is very important. Science is not standing. The private sector in the sphere industry is developing and expanding its limits of influence. The state must control the issues of security, peace, and development of society. We shouldn't have to change and reform the legal framework of our predecessors. However, we have to appreciate what we already have. The moon, other planets, and asteroids contain many different minerals, gases, and water that can be used to provide raw materials, energy, and livelihoods. The development of space resource activity is happening now. In the absence of a clear framework for the management of these activities, there is a need to explore the various concepts that are being discussed to ensure that they meet their existing contractual obligations on space resources. First of all, during studying the issue of regulating of extraction and use of space resources, we must take into account the Outer Space Treaty and the Moon Agreement, which are leading in the field of space legislation. For example, Articles 1, 2, 6 of the treaty and outer space highlight the main aspects, principles concerning utilization of space resources. The possibility of appropriating these resources is becoming a controversial issue today. Therefore, when creating new regulations, we must take into account these laws. The use of space resources has a huge potential for the future of mankind. We aim to create a favorable environment for activities with space resources. We have written the draft law of Ukraine on extraction and use of natural resources of the moon and other celestial bodies. It consists of 7 sections and contains 28 articles. Let's look at them. Section first, terms. These sections conclude definitions of terms and concepts. Questions concerning rights to space resources, the purpose of extraction, explanation of natural resources, and main principles of extraction. Section 2. Organization of extraction and exploitation of natural resources from space bodies. This section devotes to such questions as right to resources, operators' rights and obligations, liability for violation of legal requirements in the extraction and use of space resources, question concerning avoidance and mitigation of potential harmful effects of space resources, jurisdiction and control over products created in space used in space activities. Next section, section 3, technology, equipment, devices. This section devoted to the questions like conditions of application of technology, equipment, and devices during the extraction, exploitation of natural resources of space bodies. Question concerning determining the possibility, standardization in the field, and state supervision concerning the extraction and exploitation of resources of space bodies. Next section, section 4. General requirements for space activities during the extraction and exploitation of resources from space bodies. This section contains articles such like certification of extracted resources of space bodies, registration of extracted resources from space bodies, and Article 20 is devoted to question concerning admission, restriction, and prohibition of exploitation of resources of space bodies. Next section, section 5. Ensuring the safety of space activity during the extraction and exploitation of resources from space bodies. This section devoted to such questions as state supervision over the safety of extraction, public safety, protection, incidents and emergencies, compulsory insurance in the extractions and use of space resources, and also concerning liability for damage caused during the extraction and use of resources of space bodies and compensation for damage. Next section is section 6, international cooperations. This article devoted to the questions like purpose and general principles of international cooperation. And the last section is section 7, final provisions. Article 28, responsibility for violating the law during the extraction and use of space resources. Summarizing the above, it should be noted that the establishment of legal framework for the extraction and use of resources from space bodies is an extremely important issue today. International recognition of the legality of the use of space resources can provide support for the legality of domestic laws on the use of space resources. Thank you for your attention.
Dear Inessa, thanks a lot for your interesting presentation. So, as I understand, the presenter is ready to answer your question. So, you are welcome to ask your questions, dear colleagues.
Dear Inessa, I have a question. Today, the issue of exploitation of space resources is very controversial. What is your position on this issue? Is this outlined in your draft?
Thank you for your question. You are right, this question is really very controversial because there are different views on these issues, but our opinion that we are not ready to such difficult rights, and to make appropriation for the resources, it will be too difficult for us now. So our opinion is that we couldn't have right of appropriation. There are lots of different activities like transportation, utilization, exploration, and etc. Thank you.
Dear Igor, are you satisfied?
Thanks for the answer.
Okay. The other questions, dear Sanem, do you want to ask something? Please, welcome. Dear Sanan, you can ask your question. You raised the hand that you have question. No? Okay. So if, please switch on your microphone to make questions. Okay. Ask your question.
Я первый заместитель генерального директора Национального аэрокосмического агентства Азербайджана, профессор Топик Сулейманов. Очень подробное описание мы слышали здесь. Конечно, это актуально. Такие вопросы. Сейчас нет возможности нашей совместной встречи. Конечно, раньше это все происходило. Я надеюсь на дальнейшее сотрудничество с космическим агентством Украины. У меня было очень много друзей там. Тогда-то мы встретились в Москве и других городах. Я думаю, что очень интересная тема сегодняшней научно-практической конференции. Благодарю за приглашение тоже.
Мы вам тоже очень признательны, очень настроены развивать международное сотрудничество. Очень приятно за ваш интерес к нашим амбициозным проектам. Спасибо, будем рады представить наши следующие презентации. Надеемся, что они тоже будут чем-то вам полезны. So, dear colleagues, if we can say that first presentation discussion is finished, so it's time to go to the second presentation, and I heartily invite Oleksii Padun to make his presentation, Earth's Artificial Electromagnetic Field. So, dear Oleksii, you're heartily welcomed.
Thank you. My name is Oleksii Padun. I'm a chief design engineer at Science and Space company, and I want to present you the project of artificial magnetic field. So the project artificial magnetic field. Nowadays, people face one of the most severe dangers from space. It's solar wind. It is well studied how dangerous it is, but it's not well studied how to protect ourselves from it artificially. Our planet is protected from it with a magnetic field, which you can see on the picture. Nevertheless, even with this natural protection, there were some incidents in the past when solar wind damaged our infrastructure and industry. There were several sunbursts occurred and they destroyed infrastructure on Earth. They damaged telegraph and even a power plant. And that was on Earth. What would be in space? It is clear that such a sunburst will cause fatal damage for astronauts and electrical circuits outside the magnetic field of the Earth. So how can we protect ourselves, our space stations? We should create our own magnetic field. As you can see on the slide, electromagnet will create the magnetic field which has same magnet lines as the Earth. So the decision was made to place a coil inside the station which will produce the field with the same magnitude and the direction as the field on Earth. The mathematical model which is used in the calculation is Biot-Savart law, which is derived from the two Maxwell's equation about magnetism. And as you can see, it describes magnetic field around the element of the wire. And our coil is a circled wire. On the left side is the magnetic field. On the right side, before the integral, is magnetic constant. And under the integral, it's current, differentiate element of the wire, and displacement vectors in appropriate powers. So the simulation of the magnetic field was done based on this theory. And it was done using the finite element modeling. You can see results of the simulation on the slide. The calculation method was verified through the comparison of the results for the simpler problem with the mathematical model presented above. As you can see, the magnetic field corresponds completely to the magnetic field of the planet Earth, so it will secure the safety from solar radiation and right magnetic field for biological processes of the organisms on the station. And here are some of the specifications of the magnet design. It is done using the copper wire and is powered completely with the station resources. To secure uniformity of the magnetic field, the non-magnetic materials must be used to dock it safely inside the station to connect it to the station's construction. And the main application of the system is the space station, but it's not limited to it. Humanity has a far-going plans of colonizing other celestial bodies, and the system can easily be integrated to the ground-based scientific station on Mars, Moon, or other planet or satellite where the magnetic field is needed. So, as a conclusion, the system described creates a magnetic field which equals the Earth's magnetic field in terms of magnitude and direction. This field solves one of the biggest problems of the long-term survival in space: solar radiation and biological magnetic background. Thank you for your attention. Now I'm ready to answer your questions.
Okay, please. Super. So, dear colleague, the presentation is finished. Our presenter, Mr. Olexii, is open for your questions. If somebody has questions, please feel comfortable. Do we have any questions? So, Mr. Olexii, thanks a lot. We have no questions for discussion. Thanks a lot again for your presentation.
Yeah, thank you for the opportunity to present it.
Now, according to our program, it's time for the third presentation, and I heartily invite Polina Dolishna to make a presentation of ultralight classic academic vehicle, A in space. Please start your presentation, dear Polina.
Thank you. Good morning, ladies and gentlemen. I'm Polina Dolishna, and I am a research and language assistant at Science and Space Company. I would like to feature the presentation MICROLINE-UNIVERSAL. So, let me first share my screen. Can you see it?
No.
And now?
Still not. Oh. No.
Yeah, can you see it?
Now I see my face, but not your screen. Please try again.
Mm-hmm. Like, it is sharing the conference, but not my presentation.
When you push the button, you can switch the window, which one you will share.
Mm. And now?
Not.
Okay, that's really strange.
I am sorry. Next presentation.
Okay, maybe Polina.
Okay, I'll try.
Continue our program, and you will join us later after the last one. Dear colleagues, sorry for these technical issues, and let's move forward according to our program. So I heartily invite Yehor Yablonskyi to make his presentation, Artificial Gravity in Outer Space. Please, Mr. Yehor.
Yes, good morning. Just give me a second. I try to. Can you see this?
Yeah.
Yeah, okay. Well, hello, dear participants. First, I would like to thank you for coming to our conference. This is have a great importance to us. Some words about me. I am Yehor Yablonskyi. I'm 19 years old. I'm studying third course on National Aviation Institute KPI in Kiev. I studied in the Faculty of Avionics. Well, let's begin in our presentation about artificial gravity concept. So, what is gravity? In a simple language, this is what doesn't allow us to jump about our heads on Earth. Yeah. She really helps us to live. Without her, we can't stand in any way. But what to do when gravity is needed outside the Earth, let's say in space? For this was invented artificial gravity. For a long time, writers and science fiction writers have came up with this name and often used it in their works. But then this was just a fantasy, and today no longer. So the first thing a person encounters is the absence of attraction in the deterioration of the physical health. There are three main points. First, this is muscle atrophy. Second, loss of orientation in space. And third, maybe incorrect works of the circulatory system. And with our invitation, these things can be solved. So we have invented a method that is unique in its kind, magnetic. What is its sense? Well, a person by himself is not attracted to a magnet, but other magnets or metals interact very well with it. So why not to use this power? Our team and I have came up with the suit that that will be all laced with magnetic threads. There will be more of them and the flat surface of the body. And if a person puts on the suit over a magnet of 13 power and direction of magnet fields, then he no longer dangle chaotically. So on this picture you can see the concept picture of this suit. So together with us, several main problems are being solved. You no longer fly weightlessly throughout the spaceship. There is no muscle atrophy because you need to constantly resist the force of the attracting magnet. And you manage to deceive the body and your vestibular apparatus since you have a fulcrum. And the problem with the vessels is solved simply by increasing the pressure of the suit on your body. So the red line on the suit you can see is imitation. It's just for your visual effect. This is a magnet cable that will give the force with this suit and you in the suit to the magnet under your feet. We believe that this invitation is innovative and will become a real breakthrough in the field of science. Thank you for your attention.
Dear Yehor, thanks a lot for your interesting presentation. And we will be glad to hear any questions to our presenter.
Yes, I do have a question. Yehor, can you please tell us what is the power of one of the magnets which is used in the system?
Thank you, Lusha, for your question. Yes, this question is very important because it is one of the main things you must know about this magnet. But I hasten to disappoint you that that only one magnet will be twice as powerful as your kettle that you use in the kitchen. So about 3 kilowatts. Thanks.
Oh, thank you for your answer. Thank you.
Do we have any questions more? Okay. Thanks a lot, Yehor, for presentation, and thanks the participants of discussion. We are very glad that any questions arise. So our discussion is very important for our conference. So according to our program, we have our fifth presentation, and I heartily invite Levenko to make a presentation, ZENIT mid-class sea launch vehicle.
Okay, hello everyone. Do you hear me?
Yeah.
Okay. Hi. Thank you for this opportunity to make my presentation in this conference. And I wish all participants of this conference the successful part in this event, good event. Okay. Some words about me. I am the advisor of General Director of well-known Yuzhmash, state enterprise, Yuzhny Machine Building Plant. And now I try to represent some our project which consists on launch vehicle. Okay, here we go. Okay. Our project is the lightweight launch vehicle to provide launch services to lightweight satellites and other launch services. Main characteristic of these launch complexes. This complex is marine based. It stay on self-propelled floating dock with 10,000 tons capabilities. We use our experience in production of launch vehicle, all our production facilities and our workers, employers who have very huge experience in production of space technique. Okay, our launch vehicle developed into deliver to orbit 700 kilometers, about 700 kilos. Why we use a floating platform? Because we have some experience in manufacturing and developing of sea launch project, well known in all world. But this project now is bankrupt, and we want to renovate this project in lightweight class and low cost with low cost possibilities. Okay, here you can see the floating platform which we use in this project. This is ready to market composite floating dock, which product in Polina enterprise located in Kherson, Ukraine. And after our modernization and mount of our rockets, you can see the final view of space launch complex, which we can transportation into everybody where we can float in this platform. Okay. Some information about the launch vehicle, which we developing now. This is traditional rocket with space-proven technical solution with classical tandem component with two-stage diameter of this launch vehicle 2.4 meters and the height about 24 meters. In the second stage, in the first stage, we used the proven and used now rocket engine RD-8, which used on launch vehicle ZENIT 2. Right now we can produce and test this rocket engine. And as we think this solution can achieve the low-cost characteristic of this launch vehicle. Right now, we're developing the main engine, which located in mountain on the first stage of this launch vehicle. This engine may have 50-ton thrust. Right now, we're testing pre-burn for this engine, and our assets about 1-2 years, we will make this engine to the market. Okay, what about cost of this project, about our assets? Totally, this project can cost $135 million, including the rocket and the marine platform for the launch vehicle. On the slides, you can see some detailed information about the realization of this project and some prices and terms to realization it. Okay, why we're working in this direction, in this project? As you know, now Ukrainian space industry have some problem in production of space technique. We not have state orders, and now we try to take some position on global market on space launch. Of course, we have the experiences and possibilities to do this task, to make this task. Okay, and we think in the future, the global market the global market of space services will rapidly grow, and we can take the position of the global market. Here you can see about contact information about this project, and I'm ready to hear your questions. Thank you.
Dear Oleg, thanks for your presentation. It was very interesting, and I hope that some of our colleagues have some questions to you. So if somebody wants to ask the question, you are welcome to ask your question.
Yes, I do have a question.
Okay.
How competitive will your company be after the success of this project on the market?
Okay, that's a very good questions. Of course, we will competitive, because all this project, the target of this project, is oriented to take part of global market, and including our low-cost solution and space-proven solution, we all have all possibilities to grow our competitiveness. Okay.
Thanks for your answer. Dear Olexii, are you satisfied?
Yes, I am. Thank you very much for your answer.
Thank you for your question.
Any more questions?
I'm sorry. Господин Олег, ну, ваше предприятие есть одно из первых предприятий в мире, которое запускало, зарабатывало ракеты. У нас сегодня присутствуют наши друзья, я не сомневаюсь, это азербайджанские наши друзья, которые сейчас решают очень сложную проблему, которую мы тоже решаем, и дай Бог, чтобы они ее решили. пройдет некоторое время. Я думаю, что про нашу конференцию узнает уряд Азербайджана. Мы моделируем ситуацию. Уряд Азербайджана желает работать из южным строительным заводом. Через сколько вы сможете сказать списку МОРа своей платформы? Вот начали работать. Запустить Украина, азербайджанский,
Запитання, Валентин Васильович. Ну, в слайдах було вказано, що орієнтовно від 3 до 5 років, в залежності від того, наскільки ми...
Господин Олег, нас слушают азербайджанцы, пожалуйста, на русском.
На русском, да, хорошо. Хорошо. Как я и показывал в презентации, основных точках, так сказать, реперных по этому проекту, по его стоимости и времени его выполнения, мы закладываем от 3 до 5 лет с начала финансирования до реализации этого проекта. На данный момент то, что требует больших усилий, так скажем, это производство и отработка главного двигателя первой ступени, маршевого двигателя. Вот. Мы надеемся, что за 3 года мы сможем выйти на рабочий вариант, готовый к рынку, к работе с этим проектом. Насколько это полный ответ или надо дополнить как-то больше?
Непонятно. Наши азербайджанские партнеры, может, хотят уточнить.
Ну, глобально через 5 лет этот пусковой комплекс может выйти в море, будет отбуксирован, может быть отбуксирован в любую точку мира и запущен.
Хорошо. Вы раскрывали смету там по частям.
Да.
Сейчас очень модно all-inclusive. Сколько же будет all-inclusive этого проекта?
135 миллионов долларов по нашим предварительным оценкам.
Спасибо.
Какая будет расклады, если это есть необходимость?
Хорошо. Это для того, чтобы сделать проект. А какая будет цена одного пуска? Приблизительно. Будете ли вы конкурентоспособны?
Все же зависит, насколько мы сможем загрузить в первый пуск этими 700 килограммами. Это кластерный запуск, и, видимо, там будет множество аппаратов. Поэтому цена будет варьироваться в зависимости от того, сколько мы привлечем клиентов на этот запуск. Но у нас есть целевая цена запуска, это $10 000 за килограмм. На этом проекте мы ориентируемся на такие цены.
10 000, сейчас 23, это очень хороший, это в 2 с чем-то раз меньше, чем на сегодняшний день. Сегодня $23 000 за килограмм. Но я про другое. Вот запустить уже ракету, которая готова. Сколько будет сам пуск? В целом. Может там быть 700 килограмм, может быть 500, может быть 250 сложный спутник. Сколько будет один пуск в серии?
Опять-таки мы ориентируемся на какие-то цены, да? Ну, я так понимаю, что порядка от 5 до 7 миллионов.
От 5 до 7 миллионов. Это да, хороший...
В зависимости, куда мы транспортируем эту платформу, где мы берем топливо, это зависит опять-таки, кто будет оператором этого пуска.
Хорошо, спасибо. У меня больше нет вопросов.
Спасибо, Антон Васильевич.
Okay, dear colleagues, very interesting discussion. Maybe somebody want to join.
Да, тут Наталья Риджец задала вопрос в чате, я его продублирую. Где эта пусковая установка будет создаваться, делаться?
Maybe in English for our colleagues. It could be more comfortable.
The Natalia Regis, it's have a question and write it in chat. From what place will that project be launched? Where I understand where it will be constructed.
Okay, I understand this question. As I say, this is marine-based launch complex, and it can launch from everywhere where we can water surface, and actually its influence from who order the launch services based on this launch complex. We can start from Atlantic Ocean, from Mediterranean Sea, from Pacific Ocean, if it needs.
I actually not this main. I mean, where this platform built.
Okay. I say about this. This platform built in Kherson, Ukraine. The state enterprise Palada. It is already in market solution. Okay. Actually, I can share a link for this production enterprise, and you can see the main characteristic of this floating platform, floating composite dock. We make, our enterprise will make some modernization of this platform in for mounting of launch vehicle for rocket. Let's understand or not?
Yeah, thanks for your answer.
Okay.
Okay, thanks a lot, dear Oleg, for very interesting discussion and a very deep understanding of these problems. And I hope that this project will be realized soon. So, according to our program, we have our last sixth presentation. And I want to invite Oleksii Padun to make a presentation of artificial islands as the way to save humanity. So you are heartily welcomed.
Thank you very much for the invitation. I'm Oleksii Padun, and I will present you our project of Space Islands. That's a long-term station to be located in space. So my name is Oleksii Padun. I'm a chief design engineer, and that's a project of science and space company called Space Islands, the way to save humanity. Humanity is growing, and in the nearest future, it will be required to leave our beautiful blue spot, planet Earth, to continue our existence in space. Our space islands will be located between orbits of Earth and Mars. But before that, the testing smaller island for 100 persons will be placed in the Lagrange L4 or L5 points in the Moon-Earth system. And this, the project mission of the island is to deploy it in the Lagrange system as the most stable point in the Earth-Moon system to save the energy of orbital maneuvers and stabilization. It will have magnetic field to secure safety from the dangerous solar wind, and it will have ozone layer to secure safety from the dangerous ultraviolet rays from the sun. The problem of artificial gravity is also solved on the island with a system of magnets located in the living zone, which will provide the force which will simulate gravity in the living areas of the island. And there is an infrastructure to make the island as independent from the Earth as possible. Space Island is an extremely complex engineering system, which includes several subsystems which will use the modernist technology of its time. The main systems are electrical, life support, recycle and renewment, artificial magnetic field, and gravitational systems. On this slide, you can see main specification of this smaller testing island to be located in Lagrange points. And this slide shows the magnetic field, as you saw it in the one of the previous presentations. It will secure the safety from the solar burst, and it is created by the big coil with a diameter of 6.4 meters in the middle of the island. The system creates magnetic field, which equals the Earth's magnetic field in terms of magnitude and the direction. And it solves not only the radiation problem, but also the biological one with the right magnetic background for organisms. Artificial gravitation. The island will have artificial gravitation, which will simulate the dragging force to the floor. And it will be comfortable to live in. It will be as comfortable to work as on Earth. It works because of the with interface of the space closes and the magnets located underneath the floor. It is also simulated by doing the finite elements method, and you can see the main characteristics of this system on the slide. Water circulation. The island will have water circulation and cleaning system, which was calculated for one person, and it is also pressurized and cleaned every time. This whole system is powered completely from the solar panel or from the backup power units, which are methane engines. Electrical system. The system uses 20 electron systems for atmosphere purposes, and it has pretty big solar panels with area of 80,000 square meters and mass of 630 tons, which produce a power of 30 kilowatts. But also it has backup power units, which could be used in emergency cases or where more power is needed. The space island is divided in several areas where people will live and work. It is a living area, relax area, scientific area, garden, and medical area. So the island is a city in space. Location of the island. The location of the island is Lagrange points L4 or L5, as it was mentioned before. Why we have chosen this place? Because it's the most stable part of the nearest space from the Earth. You don't need energy to stabilize it because even smallest derivations from this point will take the island back to the Lagrange points. So this location was chosen for our 20-meter diameter smaller testing island. Orbital maneuver to get to the Lagrange point is a Hohmann transfer. It is a flight-proven maneuver, which is the most energy-efficient way to fly there. It is done through 2 engine starts, and it is completed in 123 hours. Here's some details about flight procedure when we're doing this orbital maneuver to get to the Lagrange point. And if you're launching with a vehicle with refueling on orbit, so the one rocket starts filled completely with fuel, and the second rocket starts with payload. On the lowest orbit, they dock each other, they start refueling procedure, and then this 100 tons rocket launches to the Lagrange point. If this procedure would be implemented, it would take 118 launches to complete the space island in L4 or L5 points. Space island atmosphere. On the island, you can breathe as easy as on planet Earth, so air conditioning and cleaning system is powered from solar panels to provide proper composition, humidity, and pressure on the island. And future islands will become more and more independent by implementing the system of this interconnection between different islands. There would be delivery from asteroids and comets for mining resources, water from them. The more and more flora will be synthesized on the island, and the extraction of water from comets will be conducted as well. And these resources can be used even to build new islands and to create a system between Earth and Mars. Nutrition. The island is using the modernized technologies of food production and synthesis. So the food of plant origin will be grown on the island, while other sources of protein could be synthesized on the island, which could also be powered completely from the solar panels from electrical system presented above. Greening. The island will use Ukrainian experiments a lot. As we know, we have conducted, Levenko has conducted several experiments on board of the space shuttle. The results of those experiments could be used on our island, as well as international researchers from NASA and other space agencies. That's very important for mental health of the people on the island. So plants will be grown and it will cause a positive effect on psychological health of the crew. Recycle. One of the key points of the island is to make it as independent as possible. So recycling will be implemented as well, and it is powered from solar panels as well. But not recycled waste will be sent to a heliocentric orbit in future to take it back to safely collect and dispose. And hydrogen released from the oxygen production process can be used as fuel for incoming spacecraft. Excess could be drained or used for deorientation purposes. As a conclusion, along a theoretical physicist and mathematical solve the equations of the achievable universe, humanity can and should master the middle and far space for its residence, organization, or production, rest, or therapy. This is a question of human survival, because as Stephen Hawking said, the death of planet Earth is only a matter of time. So we can do something, and we are doing something. We are moving to space. The presentation includes innovation coefficients in its calculations as a perspective parameters. Those coefficients are calculated based on current tendencies of modern technologies in the perspective of 5-7 years. Because as we all know, when the terrestrial technologies is used in space, it becomes far more advanced. So those coefficients are calculated based on those trends and the law of accelerated development on science, technology, and social relations. You can see the coefficients which were used on this slide. Thank you for your attention. Now I'm ready to answer your questions.
Thanks, dear Olexii. Very interesting presentation, very interesting theory for humanity. So, does anyone have questions to our presenter?
Of course. So, hi. Thank you a lot for your presentation. I want to ask a question. Have you patented this project?
Yes, we have sent the documents required to make a patent already. So the procedure is currently in process. So we will secure the safety of our invention.
It's really nice. And second question is, what are the deadlines for the implement of this project and what funds are needed for its implement?
The project is a very perspective and it has far-going plans. As it was mentioned in orbital maneuver part, those amount of launches can be conducted during the 1-year period, and we can start doing it in 5-7 years approximately. But the funding of this project really depends on the current rates for launches, because it differs now dynamically. So if in the future it will become cheaper, it's clear that it will become cheaper. So we can expect several billions of dollars to launch this project.
Olexii, what is the price of the project?
Sorry, can you repeat the question, please?
What is the price of the project?
Yeah, as I have answered this question already. So the price varies for the launches, and we are highly dependent from the launch price, from the price per launch, but it still will be several billions, tens of billions of dollars.
Okay, thank you.
Thank you.
Does anyone have more question? If not, I want to say a lot of thanking word to Olexii for his presentation and our colleagues. We have our third presentation with some technical issues, so now we can come back to this presentation and try to hear Polina Dolishna with her presentation. Is her ready?
Yes, thanks. I'll try once again.
Good luck.
Thank you.
Yes.
Yes, can you see it again?
Yes.
Okay. So I'm Polina Dolishna, Language and Research Assistant at Science and Space. And I would like to feature the presentation MICROLINE-UNIVERSAL. So justification of launch vehicle production. People all over the world are trying to develop and exploit ultralight meteorological launch vehicles, though such devices weigh several tons. A rocket is designed for repeated use, weighing less than half a ton. Consequently, the cost of one launch will be much lower compared to competitors targeted at high orbits. A space rocket complex is designed to serve the world's leading universities engaged in atmospheric research and studies of the lower boundary of space. According to preliminary estimates, customers may be 12,000 universities from the United States, China, the European Union, and other countries. The use of military technology for peaceful purposes allows to launch a civilian carrier rocket at low price without a specially equipped spaceport. Project description. This is a reusable single-stage sounding carrier rocket. Launch of the rocket by the force of steam formed under the action of liquid propellant rocket engines. The flight control of the launch vehicle is carried out by deviation of the liquid propellant rocket engine in the same plane. The use of gas nozzles to rotate the launch vehicle around the longitudinal axis. The orbiter has its own propulsion system to achieve altitude and range. Here we can see some technical specifications like number of stages, diameter, length, lift-off weight, weight of the fuel, stress in a vacuum, and type of launch. And this is technical specifications of the orbiter. Same points as on the previous slide. I'll give you some seconds to look it through. Here we can see a scheme of the carrier rocket. On the left, carrier rocket, and on the right, launch canister with water. Ballistic analysis of the orbiter flight on the suboreal trajectory. Here we can see some points like eccentricity, inclination, apogee height, apogee velocity, flight range, flight duration, impact point latitude, impact point length, absolute velocity at the end of powered portion of flight, maximum endurance, dynamic pressure, and dynamic velocity pressure. All numbers are thin on this slide. Launch of the carrier rocket. So it takes less than 5 seconds at an average overpressure of 0.573 for the rocket to come out of the container. The final velocity of the rocket existing in the container is 6.755. The water is heated by hot gas from the motor nozzle, and water volume is 3.371. Advantages of the conversion method at the launch of the carrier rocket. This is the simplest low-budget option to launch a carrier rocket without a specially equipped spaceport, so no specially equipped spaceport is needed. The initial section of the launch with zero velocity is excluded, which simplifies the missile control system at the launch. Providing the missile with the initial velocity allows to improve its characteristics. The altitude and range increase for a particular missile system by 1%. The following option is universal and can be used for the lightest launch vehicles of any type. The launch equipment of the container is designed together with the rocket. Part of the equipment is placed on the rocket itself. The energy sources of the rocket are used at the start. Advantages of the project. No additional expenditure in the construction of new ground infrastructure is needed. Providing assistance to the world's leading universities, atmospheric research and studies of the lower boundary of space, capability of the orbiter to fly the distance of 650 kilometers after separation from the launch vehicle, reuse of the rocket space complex, and low price of launching a carrier rocket compared to our competitors. Cost estimate and timetable. So the investment needed to create, design, test, and produce the first spacecraft is $9 million. According to the estimates on additional one-time cost, that would be design and manufacture of the complex system of lifting mechanisms and construction of ground infrastructure for space information management and for space vehicle control, design and production of the necessary launch and pre-launch equipment. The cost estimate for the launch vehicle production is $2 million, and term of creation is 3 years. Results of the project. Consequently, launch of small satellites will be produced by universities. The demands of numerous US countries, European member states, Latin America, Africa will be met. Effective growth in revenues from the sale of subscriber equipment in the world. Protection of investor rights. All individual intellectual property rights to the complex and its individual components will belong to investors in the proportions of shares invested in the project. Investors are entitled to only exercise the rights subject to the limitations of the missile technology control regime. So MICROLINE-UNIVERSAL gives an opportunity for the mentor of the project to join the global elite, input in the name of the history of exploration and use of space, and in the medium term, not only return on investment, but also achieve great revenue. And the potential annual profit from the project can reach $20.95 million. Thank you for your attention. If you have any questions, you are free to ask.
Dear Polina, you can switch off the demonstration and we can move to discussion. If somebody have questions, you are welcomed. Does anyone want to ask something? And Polina, please switch the demonstration of your screen. Thank you. So I see that presentation was very detailed and no question arised. So
Yeah,
want to say thanks a lot again for our presenter. And dear colleagues, I see that program of our conference is accomplished, and it's time to make the final speech from Valentin Halunko, the president and the main organizer of this conference. So you are welcomed, dear Mr. Valentin.
Thank you to all conference participants. The results of the conference will be sent to all participants. The result on conference will be publication in the article on our magazine, Advanced Space Law. This launch project will be implemented with foreign partners. Thank you very much.
Thanks for your speech, dear Valentin. And traditionally, the moderator have to underline the results of the conference. So let me say a couple of words to finalize the conference achievements. First of all, I want to say thanking words to all the presenters and discussion participants. I hope that presentations were very interesting. Also want to underline that the research achievements were presented. These research were presented by Science and Space LLC, Scientific Institute of Maritime and Space Law, and National Academy of Sciences of Ukraine. So these materials were dedicated to legal regulation of extraction of natural resources on the moon and outer space bodies, Earth's artificial electromagnetic field, artificial gravity in outer space, artificial islands as the way to save humanity. I think that these programs have a very big scientific and practical future. Also, the business projects of Ukrainian space corporations were presented. The first one, Space Rocket Complex MICROLINE-UNIVERSAL, academic carrier rocket with automobile start. And the cost of this project is $9 million, and the terms of realization is 2 years. And the second business project is the ZENIT mid-class sea launch vehicle, the commercial project of the driver for the carrier rockets with high potential profit. Its cost is $140 million, and the term of realization is about 3 years. So, dear colleagues, I want to say again the thanking words to all of you, to all the participants, and to all the people who joined the conference. I think that today we tried to establish the platform for future collaboration. So thank you again, and hope to see all of you at our future events, dear colleagues.